Welcome to the second lesson in our algebra series for the digital SAT math. Today, we explore linear equations that have infinitely many solutions or no solution. The first example, 4bx minus 9 equals 5 times the quantity x plus 1 plus 3 times quantity x minus 2. In the equation above, b is constant. If no values of x satisfies the equation, what is the value of b? Our goal is to find the value b that results in no solution for x. Let's break it down step by step, just like we normally would when simplifying. We expand the right side of the equation by distributing the 5 and 3. This gives 5x plus 5 from the first part and 3x minus 6 from the second. We combine the like terms on the right side. 5x and 3x becomes 8x, and 5 and negative 6 becomes negative 1. So, to the right side simplifies to 8x minus 1. Our equation now becomes 4bx minus 9 equals 8x minus 1. Our next step is to gather all the x terms on the one side of the equation and constant term on the other. Let's move the 8x from the right side to the left. We do this by subtracting 8x from both sides. This leaves us with the 4bx minus 8x minus 9 equals negative 1. Let's move the constant negative 9 from the left side to the right. We do this by adding 9 to both sides. This gives us 4bx minus 8x equals 8. Now we have all our x terms on the left. Notice that both 4bx and 8x have x as a common factor. We can factor out x, which leaves us with a quantity 4b minus 8 times x equals 8. Now here's the crucial part of the problem. For a linear equation in the form ax equals c to have no solution, two conditions must be met. The coefficient of x, a must be 0, and constant term c must not be 0. Our equation, the quantity 4b minus 8 times x equals 8. Our a term is 4b minus 8, and our c term is 8. Since our c term 8 is clearly not 0, we need to ensure that our a term, the quantity 4b minus 8 equals to 0. So we set 4b minus 8 equals 0. We find that b equals 2. Therefore, when b equals 2, the equation becomes 0x equals 8, which simplifies to 0 equals 8. This is a false statement, indicating that there is no value of x that can satisfy the original equation. And that's our answer, b equals 2. In the next example, we are given the equation 1/3 times the quantity 9x plus 6, then subtract the quantity 2 minus x equals cx plus x plus d. The problem states that this equation has infinitely many solutions, and we need to find the value of c minus d. Let's start with the left side. First, we distribute the 1/3 into the first parenthesis and the negative sign into the second parenthesis. 1/3 times 9x gives us 3x, and 1/3 times 6 gives us 2. Negative times 2 is negative 2, and negative times negative x is positive x. So the left side simplifies to 3x plus 2 minus 2 plus x. Combining the x terms, 3x plus x equals 4x. Combining the constant terms, 2 minus 2 equals 0. So the left side simplifies to just 4x. Now, let's simplify the right side of the equation, cx plus x plus d. We can combine the x terms here. We have a cx and we have a x, which is the same as 1x. So combining them gives us the quantity c plus 1 times x. The constant term is d. So the right side of the equation is quantity c plus 1 times x plus d. Now we equate the simplified left side with the simplified right side. For x equals the quantity c plus 1 times x plus d. Let's think about the equation ax plus b equals cx plus d. To have infinitely many solutions for x, it must be true that a equals c and b equals d. Let's break down why this is the case. Let's rearrange our original equation. We need to gather all the x terms on one side and all the constant terms on the other. By subtracting cx from both sides, we have ax minus cx plus D, B equals D. By subtracting B from both sides, we have AX minus CX equals D minus B. By factoring out x on the left side, it becomes the quantity a minus c times x equals d minus b. Think about what it means for an equation to have infinitely many solutions. It means that any value we choose for x will make the equation true. So if the coefficient of x is 0 and the constant term on the other side is also 0, so 0 equals 0. This statement is always true no matter what values x takes on. In this case, the coefficient of x, which is a minus c, must equal 0. If a minus c equals 0, then a must equal c. The constant term on the right side, d minus b, must also equal 0. If d minus b equals 0, then d must equal b. We have shown that if an equation ax plus b equals cx plus d has infinitely many solutions for x, it must be that a equals c and b equals d. Let's go back to our original simplified equation. For this equation to have many solutions, the coefficients of x on both sides must be equal. On the left, the coefficient of x is 4, and on the right, the coefficient of x is c plus 1. Setting them equal, 4 equals c plus 1, then c equals 3. Next, the constant term on both sides must be equal. On the left side, our simplified expression is 4x, which can be thought of as 4x plus 0. So the constant term on the left is 0. On the right side, the constant term is d. Setting them equal, 0 equals d, so d equals 0. We are asked to find the value of c minus d. We found c equals 3, d equals 0, therefore c minus d equals 3 minus 0, which equals 3. So the value of c minus d is 3. Let's wrap things up with a quick summary. We start with the equation in the form ax plus b equals cx plus d. Depending on the values of a, b, c, and d, this equation can have one solution, no solution, or infinitely many solutions. For the one solution, this happens when the coefficients of x are different. In other words, a is not equal to c. Geometrically, that means the two lines have different slopes and intersect at exactly one point. For example, 3x plus 4 equals 2x plus 1 has one solution, x equals negative 3. For the second case of no solution, this occurs when the coefficients of x are the same, but the constant terms are different. So a equals c and b not equal to d. In this case, the two lines are parallel and will never meet, meaning there is no value of x that satisfies both sides. For example, 3x plus 4 equals 3x plus 1 has no solution because subtracting 3x from both sides gives 4 equals 1, which is false. Case 3, infinitely many solutions. This happens when both coefficients of x and constant terms are same. So a equals c and b equals d. Geometrically, that means both sides of the equations are identical and graph represent the same lines, so every point on the line is a solution. For example, 3x plus 4 equals 3x plus 4. That is always true no matter what x is. When you see an equation like ax plus b equals cx plus d, ask yourself two quick questions. Are the x terms the same? Are the constant terms the same? Your answers will tell you everything you need to know. That's it for today. Thank you for watching, and I'll see you in the next one.